Alright, this is section 2.5, implicit differentiation. What we're going to do here is we're going to just be able to distinguish between functions in implicit form versus explicit form. And then you're going to learn how to do implicit differentiation to find the derivative. So the essential question here is how do we differentiate equations with other variables? Okay, so we have some guidelines for implicit differentiation, and then the big difference here is first we differentiate both sides with respect to x, and then algebraically we're going to collect all the terms with dy dx on the left side and all the terms without it on the right side of the equation, and then we're going to factor dy dx out, and then we're going to solve for dy dx to give the actual derivative value. So if you need to, go ahead and take a second and pause this video so you can write down these guidelines. Alright, so our first example just shows you, and you all know this, the derivative with respect to x of x cubed is going to be 3x squared. Okay, where it gets a little different is if I take the derivative with respect to x of 3y squared, or sorry, just y squared, we usually go ahead and take care of it the same way we did with the previous. So this would become 2y. But because this right here does not match this right here, every time this doesn't match, we have to put on a dy dx at the end of it. And that's going to be multiplied, but we don't write the multiply out. So the derivative with respect to x of y squared is 2y dy dx. Okay, so when we start to look at real examples, okay, so we want to find the overall dy dx with the equation y cubed plus y squared minus 5y minus x squared is equal to negative 4. And that's what this interesting shaped graph, that's what the equation creates. So what we do is we go ahead and let's go ahead and start by I'm going to rewrite the equation. So y cubed plus y squared minus 5y minus x squared is equal to negative 4. So the derivative of y cubed is going to be 3y squared. And then what I have to do is I have to put dy dx at the end of it. Okay? And then plus the derivative of y squared is just 2y dy dx. The derivative of negative 5y is negative 5 dy dx. The derivative of negative x squared is just negative 2x. And the derivative of negative 4 is 0. So now we've differentiated both sides of the equation. Okay, so now what we need to do is we're going to take everything with the dy dx in it. So these three terms are going to stay on the left-hand side. This term here is going to move over to the other side. So I'm just going to rewrite it. So 3y squared dy dx plus 2y dy dx minus 5 dy dx is going to be equal to 2x. And then the next step is to factor out the dy dx's from all the terms on the left-hand side. So I'm just going to write that first. Oops, not equals. So this becomes 3y squared plus 2y minus 5 is equal to 2x. Okay, and then we just take this here and divide it over to the other side. So that gives me a final answer of dy dx being equal to 2x divided by 3y squared plus 2y minus 5. Okay, so that is the derivative of our implicit function. Okay, in this problem we're going to determine the slope of the tangent line to the graph of x squared plus y squared, 4y squared is equal to 4. And that's this ellipse right here. And then they want to know what the slope is at the point square root of 2 and then negative 1 over square root of 2, which is right here. And they even show you. So that looks like the slope is going to be some value that's a little less than 1. Okay, so let's go ahead and differentiate this implicit function. So here I'm just going to rewrite it again. So x squared plus 4y squared is equal to 4. Okay, so the derivative of this, the derivative of x squared is just 2x. The derivative of 4y squared is going to be 8y dy dx. And of course the derivative of 4 is just 0. So again, we just take, this is going to stay on the left side, this needs to move to the right hand side. So I'm just going to rewrite this as 8y dy dx is equal to negative 2x. And now I'm going to solve for dy dx to give me dy dx is equal to negative 2x over 8y. And I'm just going to quickly simplify that to negative x over 4y by dividing both sides by top and bottom by 2. So this is the derivative of that implicit function. Now to find the slope, we're going to take this x value and this y value and plug them in down here to figure out our slope. So the slope is going to be negative square root of 2 over 4, and then our y value, negative 1 over square root of 2. And then this simplifies to negative square root of 2 over negative 4 over square root of 2. And through with some algebraic simplification, we get square root of 2 times square root of 2 over 4, or 2 over 4, or 1/2. So the slope is m is equal to 1/2. And if you look at the graph right here, this little graph shows, it looks like it's going to be about 1/2. Alright, so the next example has us taking the derivative of a lemon skate. So that's this little figure 8 shape right here. And it wants us to find the slope at the point 3, 1. So it looks like it's going to be a value probably a little bigger than 1. So we're going to start by taking the derivative of 3x squared plus y squared squared is equal to 100 xy. Okay, so this is going to be a little more challenging. So what I want to point out here is this derivative requires the chain rule. This derivative requires the product rule. So when I set this up, the derivative of the left-hand side, this 2 is going to move down in front, so I'm going to multiply it by the 3 to get 6. So that becomes 6, and remember the inside stays the same. Okay, and then 2 minus 1 in the exponent leaves just 1, so I'm not going to change it. And now it's multiplied by the derivative of the inside. So the derivative of x squared is 2x, plus the derivative of y squared is 2y dy dx. Remember that dy dx gets put on after every single time we take the derivative of y. Okay, so that is the left-hand side. The right-hand side is a product rule. So I'm going to let the 100x be our f, the y be our g. So if I set this up right, it's going to be g times the derivative of f, and the derivative is 100. So this is going to be equal to 100 y, and then f times the derivative of g. Well, f is 100x, and the derivative of the y is going to be dy dx. Okay, so this has got quite a bit going on here. Sadly, what we have to do is, because we have this being multiplied by this, we're going to have to distribute this out. So I recommend do this distribution first, and then multiply the 6 in. And then what I'd like you to do is go ahead and try it, pause the video, and then start it back up, and you can see what I got. Alright, so if you did it correctly, you'll get 12x cubed plus 12xy squared plus 12x squared y, and then the dy dx, plus 12y cubed dy dx, and then of course that equals 100y plus 100x dy dx. Okay, so again, now we have to take everything with dy dx and move it to this side, and everything without and move it to that side. So on the right-hand side, this term moves to there. On the left-hand side, this term is going to move over here, and so is this term. Right, so that's going to give me, okay, so by moving that, I've ended up with 12x squared y dy dx plus 12y cubed dy dx minus 100x dy dx is equal to 100y minus 12x cubed minus 12xy. And then that simplifies to, so now I just factored out the dy dx, and I'm left with this right here. So now I'm just going to divide this over to this side, and then that'll be my final answer. So my answer is 100y minus 12x cubed minus 12xy squared, all divided by 12x squared y plus 12y cubed minus 100x. Now, that's the derivative. So to get the slope, I'm going to plug in 3 for x and y for 1, and that'll give me, so that gives me 13 over 9. And feel free to use a calculator to get that. So that's the slope of this value right here. So 13 over 9 is our final answer. So we'll kind of pause this lesson right here. What I'd like you to work on for Friday is page 146, 1 through 15 odd. And then we'll go over the rest of the section on Friday when I'm back.